Okay, good afternoon, everyone. Thank you very much for coming. I realize it's the very last talk of the entire OpenStack Summit, so I especially appreciate your being here, the stalwart few. And today I'm going to talk about steps to optimizing OpenStack resource utilization for VNFs. So just to make one thing clear at the beginning, it's really the first steps to optimizing. So it's really gaining visibility into our OpenStack infrastructure through monitoring. But the ultimate goal is to optimize utilization by tying OpenStack services together. And I'm in with the HQ, the headquarters planning team for Verizon Wireless. Okay. Let's see. How do I advance the slides? Sorry. Oh, okay, great. Okay, great. This is just a summary slide. I think probably most of you have already heard of Verizon, but we do serve more than 98% of the US population, Verizon Wireless does, as well as 99% of Fortune 500 customers, and that'll become relevant to the rest of the talk because I'm going to talk about some of our enterprise customers. So on this very next slide, this is a offering of Verizon Wireless for enterprise customers. So many businesses may have a need to track information through wireless devices. For example, deliveries. If you have a flower delivery service, you may want to track when the flowers leave the store, when they arrive at an intermediate point, and when they arrive at your customer and are finally delivered. So this allows, I mean, that's just a very simple example, but you can imagine there are many examples where you would need to tie together mobile telecommunications with a business use case. So maybe the next question is, how do we support this? And what is, just a very simple high-level view of the architecture look like for this? And so we have our, maybe these are the cell phones of the employees of the company, and they communicate through a wireless router, through a radio antenna network, to the private network, and then finally to the customer network. So for this part here, the private network, what supports that? Well, since we're at an OpenStack conference, you may have already guessed that we've been moving more and more of that to the OpenStack virtualization. So, and my particular role in my team is I have a focus on monitoring. So how do we make sure that all of this equipment is in good condition, is functioning the way we expect it to? So we do that through several ways: alerts, metrics, logs, key performance indicators, and metadata. Now, we may not have all of those elements for every single network element, but we do our best to get whatever we can. So I'm going to go through some examples for sample sites for hardware, OpenStack data that we collect, virtual machine data, and finally the virtual network function data, so that's our application data. Okay, so we'll start with hardware, and I color-coded this a little bit. Okay, so here are just some sample metrics for hardware. So we get these from our ILOs. Typically, it includes, just basic SNMP availability. Is it available? We may miss an SNMP message from time to time. So, but maybe that would bear looking into if that one's erratic. What's the reason for it? Then we also have the current temperature. That's important. As we found out in our lab, we didn't quite have adequate air conditioning at certain points in time, and we definitely found out our equipment doesn't like that. So we monitor that pretty closely. And then just other basic hardware metrics. So another view, a larger view of temperature, and just something as simple as the fans. Are both fans functioning? Do we have those operational? Pretty basic, but important. So then what kinds of alerts do we get for our hardware? So for this particular sample, I checked in the system, and Didn't find any alerts at all. So, okay, does that mean that everything's wonderful, or does it mean that somehow we don't have alerts configured? Well, let's broaden our search. And so I broadened it to just include all of our ILOs. And sure enough, we see a couple, actually there were more than a couple, but a couple examples pop up. And these look kind of not very good if they're critical alarms. So I actually, since I was putting the slides together a little bit close to the time I was going to give the talk, I talked to the operations team yesterday and found out these are actually sites that are being configured. This is not a bad thing. This is expected. So, okay, and then logs. That's another key component. So far we've gone through metrics, traps. These are logs. So this is just kind of an initial view of the raw volume of logs that we're getting from our ILOs. But we can also break that down into a textual listing. So here, these are pretty consistent. It looks like we're having some kind of DNS issue. So maybe that's something that could be addressed, if it's actually something that's causing an issue in the network, it may not be. Okay, so any questions on hardware before I go on to the OpenStack part? Yeah?
Is all your hardware the same?
No, no, it isn't. Actually, we have different hardware for computes and controllers. And of course, one piece I've left out of this is our storage. So we actually do check, we have different types of storage equipment too, whether it's EMC or NetApp in our network too, so that we have to monitor that as well.
So all of that's aggregated together?
Well, we kind of represent each element separately, but yes, so I mean, we do need to tie it together at the OpenStack layer. So for example, if there's a Cinder volume that's hosted on, whether it's EMC or NetApp or some other hardware, we need to, and then there's the compute that's running, Nova, then we need to know like which VM, what the correlation is there. Okay, so, and that anticipated the OpenStack part a little bit. But so for OpenStack, this is just a very high level view. So the very first thing we do is something that we call OpenStack Assurance. So we would check each service, that we expect to be running. RabbitMQ, Pacemaker, MariaDB, we want to make sure that everything's basically healthy. So that's just kind of what we call assurance. And then also all the services. This is just like, can we do a basic, this was actually from when it was coming up. So not everything is green here. Usually in production it would be more green. Can the API for Nova or Cinder or Glance, is it responding with the latency that we expect? Okay, so this goes into a little bit more detail about rabbit queues. So one thing that we found is not good is if our rabbit queues are growing without bound. Here we see that the lines are very flat, so that's actually fine. And we could even see some variation, as long as they're not just going straight up. That's not good when they're going straight up. Okay. So then for the specific elements, for OpenStack, the director, and just focusing on a single metric for now, CPU utilization, we don't see a lot of CPU utilization on the director. But once the overcloud's deployed, we don't really expect to, so that's fine. And then controllers, a little, moderate amount of utilization. And then a few more metrics. These are excerpted from a dashboard that our operations folks put together. And what we found is that, once things go into operations, they like to put together their own dashboards with metrics the way they like to see them. So this is an excerpt showing CPU and interface usage in and out, just for the controllers. And so if we drill down a little bit, we might want to look at memory for a sample controller. So this shows a few different memory metrics that we're tracking. And then CPU utilization for sample compute. So this particular site has 95 computes currently, so we can graph them all on a single graph, and that's the result. Or we can also drill down individually too. So one comment that I wanted to make before we leave this OpenStack topic is about the OpenStack API, because those of you who are familiar with Keystone will know that when you make a request to Keystone, you do it, at least by the default rules, you do it either as a member or as admin. And so, but with this need to monitor networks, we think that there's a real case for having either, whether you call it a read-only role or an auditor role, to have that supported natively in OpenStack. There's active work going on in the Keystone project to support that. It is a big project because it doesn't really apply only to Keystone, but to all OpenStack services, because Nova, Cinder, Glance, they all have to be able to support this concept of a read-only role. Maybe there are lexical ways to make it simpler. Maybe every list command is okay for read-only by default. Maybe every create command is not okay for read-only by default. Maybe you can simplify it a little bit, but it still is a big enough project that it's not expected to be, really implemented till OSP 16, although hopefully there'll be at least a start on it by Rocky. Okay, so that gives you a flavor for OpenStack. For the virtual machine, we can look at individual VMs. Often we collect basic NetAS and MP stats for individual VMs. So then even if we don't have the specific application stats, which we would often get via REST API, at least we'd have basic NetAS and MP, what's the CPU, what's the memory, disk utilization. And then we can also use other tools. This is a freely available statistics package. Actually, there are thousands of packages that are written for it. And I actually I like it a lot. So I'd encourage you, if you're interested in statistics, to try it. So anyway, this is an R plot, and this actually breaks down, so I'm kind of building up to VMs here. So an individual VM, of course, is comprised of multiple CPU cores. This is just, I just picked CPU core 0, so it's just the plot of the utilization for a single CPU core, and this is, it's actually very low utilization, it's only 5%. So that's just the first one that I picked. So then I said, well, let's do something a little bit more interesting. Let's at least look at NUMA siblings, because we have hyper-threaded cores, as I'm sure many people do. So let's just take a couple of samples. Let's take 0 and 24 and 4 and 28, which we can tell from our, Libvirt statistics are siblings. Okay, so here's the first one. So now we have two, not super interesting. They both don't have much utilization. Okay. So let's go on to the next one. Okay, so this one's a little bit interesting. So we have two here, 9 and 33. So these are siblings too, actually. And I only see a single line, which is at 100%. It's kind of interesting. So why is that? So what happened, first of all, what happened to the other one? Well, so in R, you can jitter, add a little bit of jitter to see what happens. So I did that. So let's jitter those two lines. And when we do that, of course, our data is a little bit corrupted now because I added a little bit of jitter, but you can see that there actually are really two CPU cores that are being represented here. And they're both at 100%, so one just drew right over the other one. So why is that? Okay, it's because we use something called pull mode drivers. So basically, that's a while loop that's constantly checking and reduces overhead for telecommunications. And it uses, actually, this one uses data plane development kit, so DPDK. And the utilization is expected to be 100% for that reason. so this indicate, I mean, what might we think about this if we're trying to, conduct a project, as actually there is a project at Verizon that is attempting to say, what's the value that we're getting out of virtualization, right? How are we doing in terms of what's the cost, and can we reduce the cost? So here, if we just go back a slide, we see these two at 100%, we might say, well, clearly we can't add anything more there, but maybe that's not true, right? Maybe if we look at other metrics, which I don't do in this presentation, but certainly we could expand it to do that, to look at interface utilization. Some cases it might be memory, it might be disk, but to expand what we look at, then we might find actually we could get more utilization, more value out of it. Okay. Okay, so this is just like showing all of the 48 cores here. So with including the ones that are 100%. Okay, so this is another R graph. So this is an alluvial diagram. So basically here, so what are we looking at? This, so here on the left are the cores, okay? So 0 to 48 or 47. And then the width of each of these is representing its utilization. And then in the middle, we have our virtualization layer through Libvirt here. So these ones on the bottom are reserved, so they weren't included in our pin set. Okay, we excluded them from our pin set. These other ones are all pinned. So this one's pinned, this one's pinned, and here we, from our earlier slide, I don't know if you remember, but it was 9 and 33 that were the ones that were 100%. So we can see those are very wide because they're used at 100%, and they're going into this instance. And then there's an instance on the top here. So then after this stage, I mapped it to, well, okay, that's nice. We know what we have for our Libvirt layer, but what do we have for our Nova layer? So here we have the Nova VM name, which is a Sonos or Ribbon SBC, and then we have an MME up here. So that's a mobility management entity. So it's something we use in our networks a lot. But the idea of doing something like that is to show the utilization of each layer and how it carries through. Okay, so that covers a little bit on virtual machine. Finally, a virtual network function. So this is just a small dashboard from our operations team showing the application layer just for a region. And very high level, green, everything's good. Red, probably need someone to look at it. And then, okay, so then starting again with traps, I just pulled up a sample VNF and looked to see if there were any traps. And there is one kind of a low severity, the notice severity, which isn't really very high. And it's just a notice to say that it failed over to its geo-redundant pair. So our networks are designed with geo-redundancy to be resilient. Okay, so then what metrics do we have for VNFs? So this is just a sample for another of our network elements. That's a VNF showing license statistics and the destination found for a diameter routing agent. So it does routing in the network. And more metrics. Right here we have bandwidth, both for the primary site and the geo-redundant site. Okay, so then next steps. Well, clearly we have many next steps that we could take, including expanding our metrics, but also we could go farther out in the network. So I just wanted to mention that we're looking at, as a next step, doing more with edge computing. And that, of course, was presented in the keynote, one of the keynote speeches, and we've had sessions on that too. Okay, so that's pretty much what I had. So, thank you. Any questions?
Is most of that Sub 1?
Yeah, well, yeah, a lot of it is Sub 1, yeah. We do have, I put a few slides in for a POC that we're doing too, so I can show you those if you're interested. This is in the lab though, so this is for log correlation. This was a little bit interesting. So we, right, the kernel reported a memory issue, and we knew that this was happening, but it was kind of nice to see the sequence of logs that showed it happening. So then QEMU invokes the out-of-memory killer, and the process is killed, which frees 68 gig of memory. So that's in a POC stage, but yeah, there's more detail on this. So like you can look at the logs in detail too.
What kind of tools are you using for log correlation?
Well, we started doing it with this. I mean, we do use Sub 1 too, but this is based partly on, some open source tools, but it's yeah.
We also use the Shore one too.
Mm-hmm. Yeah, we don't, but maybe you do. You're with Verizon too. Yeah.
Yeah, we use a combination of Sub 1 and Shore.
Yeah, this is it. Any other questions? Or? Okay. Okay, well, thank you all for coming. Okay.